Tape 70 is equation with rational expressions. Now, if you looked at tape 69, or remember the work in the course where you're working with fractions, in that one you were working with just adding and subtracting fractions. This one is going to look like the same, except if we will now look at example 1, it's going to be an equation. We have an equation. So it's a little different. Okay, now here's where it's different. First thing you do is determine the lowest common denominator. All right, so the lowest common denominator in this case is 10. Now, listen, listen, listen. What you now do in equations is multiply everything through by the common denominator. Multiply everything through by the common denominator, and you will no longer have denominators. You now simply solve equations. So how do we solve this for x? To move this across, we do the opposite operation. And so our answer is x is equal to 6/5. Now listen again and look. You're going to multiply everything by the common denominator and no longer have denominators. That's a big difference between adding fractions. When you're adding and subtracting fractions, you keep the denominator. But in this case, we're going to multiply through and change it back to an equation, and now we go solve the equation. All right, let's look at the next example. Okay, the common denominator here is 1 and x and 2x. So therefore, the common denominator is 2x. 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 Now, a lot of students and teachers, carelessness right here, will forget to multiply over here on this side. Don't forget, you must multiply everything by the common denominator. Now, I do not necessarily say the lowest common denominator, just a common denominator. You don't have to go around trying to find the lowest. Just multiply through here such that you will no longer have a denominator. Now, combining terms. Okay, and now we divide both sides by 26, and we get x is equal to 1/2. Okay. All right, that's how simple this is in terms of the concept. Simply multiply everything by common denominator, then you have an equation, go solve the equation. All right, let's look at the next example. All right, next example, the common denominator is 3. Oops, wait a minute. Remember, if you've seen my tapes, when you're working problems like this, first thing you do is put binomials in parentheses. All right, now the common denominator is this times that. So we're going to multiply everything by 3 times x minus 7 and 3 times x minus 7. Multiply everything over here by 3 times x minus 7, everything over here. Okay, so what do we have? This divides out, and we have left 3x plus 3, and this divides out, and we have x minus 7. Now, what's your next rule of solving equations? Remove parentheses. So we have 3x plus 9 is equal to x minus 7. Now, what's your next rule? Get all the x's on one side, so moving this across and subtracting it. Moving this across and subtracting it. And now x then is equal to minus 8. All right? Now don't forget to check equations. Here's the thing you not make sure you remember. You've got to go back and put that in the original equation. And if it makes the denominator 0, then this is a no solution problem, even though you get all this to work out. If it makes the denominator 0, then it's a no solution problem. So we'll go back and check it. So we put the minus 8 here. We get a minus 5 over a minus 15, and that is equal to 1/3. All right, let's now look at example 6. Okay, first thing we do is put binomials in parentheses. Next thing we do, we multiply everything by a common denominator. Well, the denominator here is 1 and x plus 2, so we'll multiply everything by x plus 2, everything by x plus 2, everything by x plus 2. All right, then we divide out. This divides out and leaves us x plus 5. This divides out and leaves us 1. This doesn't divide out, so we have left. Removing parentheses. And so moving this x across over here and this 4 over here, we get x is equal to 2. Remember, you don't have to have x on the left side only. You can have it on either side. All right. Let's go to the next example. All right, common denominator here is x. So we're going to multiply this by x, this by x, this by x, and this by x. And what we have is x squared. That divides out. 5x. That divides out. Okay, review now. We have a quadratic equation. We have an x squared. So to solve x squared, quadratic equations, you move everything to one side. So moving this across, 2 subtract out. And now you factor, set each factor equal to 0 and solve, okay? In other words, if we don't have a constant here, then our common factor, so we factor, set each factor equal to 0, and solve for x. And so x is equal to 0 and 5. Now this is what I was talking about. If you go back and put the 0 in there, in the original equation, you get 2 over 0. That's not possible. So therefore, you mark out the 0. Okay. Number 8. All right, the first thing we do is put binomials in parentheses. Now, common denominator. Common denominator is all the different factors. Well, we have an x minus 3, and we have an x plus 1. So those are the different factors. If one of these parentheses over here or here is repeated, in other words, if you had this squared, then you have to have it squared in your lowest common denominator. Okay, so therefore, the common denominator is x plus 1 and x minus 3. X plus 1 and x minus 3. X plus 1 and x minus 3. Multiply everything by the common denominator. Well, look what happens. This divides out, that divides out, and we're left just 9x plus 5. This divides out, and we're left 2x times x minus 3. This divides out, and we're left 2 times x plus 1. Now, what's the rule? Remove parentheses. So minus 9x plus 5, 2x squared minus 6x plus 2x plus 2. Have a quadratic, so therefore we get everything on one side equal to 0. So leave that there and have a minus 4x and plus, so that's a plus 5x when I move this across. And then I have the 5 move it across, set it equals 0. Okay, how do you solve this? Quadratic formula or factor. So let's see if we can factor this. 2x and x, a plus 3, and a minus 1. So first times the first, checks. Last times the last, checks. Inside's a minus 1, plus 6 is plus 5, checks. Therefore, you set each factor equal to 0 and solve for x. So therefore, final answer is a minus 3 and 1/2. Okay? Check those in the original problem. If I put a minus 3 in there, it's okay. I do not get a 0 in the bottom. Put a 1/2 in there, okay. I do not get a 0 in the bottom. All right, so this is concludes this part of the tape. I'm going to talk about working some word problems here in a minute, but the process is if you have an equation that has fractions in it, then you multiply the common denominator times everything and get it back to either a quadratic equation or what's called a linear equation, where you just, the highest power of the letter is to the first power. Okay, let's look at the rest of the tape. Now, what I'm doing is I want you to look at the notes, the page that says applications with rational expressions. Okay, in other words, we're going to read through these 4 stated problems and look how to set them up and then how we work them like we've already discussed in this tape. All right, number 1 says, if the reciprocal of a number is added to 1/2, the result is 5 divided by 2 times the number. What? Learn to read the problem several times. It says that the reciprocal, now what does reciprocal mean? Is 1 over x, or 1 over 2, or 1 over 7, or whatever. So reciprocal then is 1 over x. The reciprocal of a number is added, so is added to 1/2. The result is, usually the word is, a lot of times in stated problems, is an equal sign, is 5 divided by 2 times the number. Okay. Now, stated problems in math books too often are written too skimpy. The writer kind of expects you to know what they're thinking. And so what you have to do is read it several times and then just pick up on looking at examples of what they really mean. Okay, so let's do this one more time. The reciprocal of a number added to 1/2 is 5 divided by twice the number. So that's how we get the equation. All right, then solving the equation is common denominator. Common denominator is 2x, so we'll multiply everything by 2x by 2x. Let's see, the x's drop out, we're given 2. 2's drop out, we're given x, and the 2x drops out. And so we go solve the equation. Now, please don't just stop there. Take that answer and put it back in the problem and see if it's right. So it says the reciprocal of a number plus 1/2 is equal to 5 divided by twice the number. Twice the number. Okay. We'll get in common denominator here. This would be 3/6, and this would be 2/6. So what we have is 5/6, and it checks. Don't forget to check your answer. Okay, let's look at number 2. If a number minus 2 is divided by the sum of twice the number and 1, the result is, oh wow. Read the number of the problem again. If a number, so that's going to be x, minus 2, if a number minus 2 is divided by the sum of twice the number and 1, the result is, that's the equal sign, 2/3. Okay, again, I would advise you to write it. Okay, read it 2 or 3 times and write it kind of as you're talking through it. Okay, now then, solving this, remember, put parentheses around binomials. Common denominator is 3 times that, so we multiply everything by 3 times parentheses 2x plus 1. And this divides out and leaves us 3 times the parentheses. This divides out and leaves us 2 times the parentheses. And so now removing parentheses, and now moving your x's numbers across. Move this x across, subtracting 3 from that leaves us 1. Moving this across gives us a minus 8. Okay, now go check it. Is a number minus 2, so a number minus 8 minus 2 is a minus 10, divided by the sum of twice the number, which is minus 16, added to 1. So we have a minus 10 over minus 15. Minus divided by minus is positive. Divide 5 into 10 and 15, and you get 2/3. Does check. We did it correct. Okay, now let's go to the next 2, which are really difficult when you're first learning how to do these. But this is where you need to watch the tape, kind of see how this works, work 2 or 3 problems in homework, and then you will pick up the pattern, okay? These are not easily done until you've practiced several problems. Number 3, pipe A can fill a tank in 3 hours while pipe B takes 4 hours. How long will it take to fill the tank if both pipes are working? Yeah, right. Pipe A fills a tank in 3 hours while pipe B takes 4 hours. How long will it take to fill the tank if both are working? Now, what the way this kind of work is you're going to look at what it takes to do in 1 hour. How much of the job gets done by pipe A in 1 hour. Okay. Well, if it takes 3 hours to fill it, then in 1 hour it's 1/3 full. Right? So you're filling the tank in 1 hour, 1/3 of it from pipe A. Well, your pipe B is filling 1/4 of the tank in 1 hour. Now together, what do they do in 1 hour? Okay. All right, does that make a little more sense what they're saying? Now you can look at the notes and do that, but what they're saying here is I'm going to come back and say this is per hour, per hour, per hour. Okay. So these 2 tanks or pipes are filling this tank with some kind of liquid, And so in 1 hour together, there's this much of the job done and that much of the job done. And that's where they come up with this equation. Right? On these kind of problems, now, if you're having two things coming in at the same time, go back and put it. Now, look at this. This is the same thing as job per hour, job per hour, job per hour. So the units are the same. All right. Then the problem is very, very simple. Common denominator is 3 times 4 times x. So we multiply by 12x, 12x, 12x. 3 divides in this 4, so we have 4x. 4 divides in this 3, so we have 3x. X divides in this, and we have 12. So 7x is equal to 12. So therefore, it takes 12/7 hours. Okay, remember now, this is the number of hours for pipe A, number of hours, so this is the number of hours for both of them. Now, double check your answer in reasoning. Okay? If it takes 3 hours for this one, and this one's going to help, then it's got to be less than 3 hours. And sure enough, it is less than 3 hours. Okay, now let's look at the example 4. All right, let's read it again. Okay, a Honda Accord is traveling 20 miles per hour faster than a Chevy S10. The Accord travels 143 miles in the same time. This is a distance. 143 miles is equal to rate times time. Okay, because you're given speed, distance, and talking about time. So there's our formula to deal with. Now what we want to do is to see what's happening here. So let's read the problem again. A Honda Accord is traveling 20 miles per hour faster than a Chevy S10. Let's stop there and read the last sentence of the problem. It says, find the rate of each one. So the rate of these is going to be an X in here. Okay. That's the unknown. Now let's go back and read the first sentence. The Honda Accord is traveling 20 miles faster than the Chevy. So this one is going faster than the Chevy. All right? Now what about the times? Okay. All right, let's read it again. The car travels 143 miles in the same time. Okay. So the times are equal. Okay. So this one travels 143 miles. Okay. In the same time that this travels 99 miles. Same time. Okay. Then what that says is that this is equal to this. The time here, which is time is equal to distance times over rate, I'm sorry. So therefore, the time of the Accord is equal to the time of the Chevy 10. So the time, the distance that the Accord travels is distance over rate, and that's the same time as that one is. So you read the problem and you read the problem and you can set up a chart like that, or you can come down and put things like this. After reading it several times, it's saying the times are the same. Then you say, here's your equation. The time of the Accord is equal to the time of the Chevy. Well, now you go back and use your equation D equals RT. T is equal to what? D divided by R. D divided by R. And now you go solve the problem. Okay? Common denominator is, put that in parentheses. Common denominator is x times the parentheses x plus 20 and x times x plus 20. X's divide out, parentheses divide out. We're given 143x is equal to 99 times x plus 20. Well, 143x plus 99x plus 198, 0. All right, subtracting over here would be 44 and 198, 0. Okay? And now dividing 44 into that comes out to be 45. Okay? Miles per hour. Okay? Don't forget to put units on the problem that you're talking about. Okay, the most important thing, as I said on these, is to read the problem several times. Don't just read it and then start trying to put an equation down from memory that you may have seen in an example somewhere. But read the problem several times. Then try to connect it to an example that you've seen in the classroom or that's shown in the textbook or maybe some of these that we have on the tapes. And then slowly work through it, talk through it. When you come back to this equation right here, talk through it to make sure these numbers make sense and what the problem is saying. Okay, hopefully this will help you. This concludes in the tape.